All right, y'all. So we're going to take some time to explore today what these little protons, neutrons, electrons, how when we put these things together and we look at the actual numbers of them, how they help us identify the element. And then once we are putting all of this information together, that is going to help us understand how these atoms of different elements bond with each other. So it's important to understand like why sodium has its makeup of protons, electrons, and neutrons, how chlorine has its makeup of protons, neutrons, and electrons. And then based on those numbers, that controls how we end up with sodium chloride, right? A lot of us have heard NaCl. Well, there's a very specific reason why it is NaCl and not Na2Cl, right? H2O, very specific reason based on those numbers of our subatomic particles in that atom, why it's H2O and not H4O7. Okay, so let's just get a couple of reminders from our stuff that we looked at before. Okay, so we had atomic number, right? And so atomic number, that told us, okay, good. Hopefully you remember that that was the number of protons, okay? Then we had the mass number, and the mass number was equal to, so mass number, that was equal to our protons plus our neutrons. So remember, protons and neutrons, those are our only thing that have mass, okay? And so that's how we kind of work with those numbers. And also just a reminder, right, in your nucleus, that's where your protons and neutrons are. So that's where the majority of your mass for your atom is going to be. By majority, we mean like all of it. All right. And so that was dealing with protons and electrons. And then we talked a little bit about charge, right? So if something was neutral versus if something had a positive charge versus if something was a negative charge. Okay, and so with those things in mind, if something is neutral, and so remember, neutrons are neutral. So when we talk about charge, neutrons has nothing to do with them. And for all of these, we want to relate it to the number of protons. Okay, so we were talking about protons and electrons, and remembering that the number of protons cannot change, right? The number of protons is identifying what element it is that we have. Okay, so for if something is neutral, it is going to be equal to the number of electrons. If something is positive, then the number of protons is greater than the number of electrons. And if something is negative, then the number of protons is less than the number of electrons. So go ahead and think about these. All right, so from there, this is going to lead us into talking about something called isotopes. And so when we think about carbon 12 versus carbon 14, things we've heard about. Isotopes are going to be atoms of the same element with a different mass number. So again, atoms of the same element, carbon 12, carbon 14, that have a different mass number, 12 versus 14. And so in terms of our subatomic particles, I want you to think very carefully about these next two questions. So again, atoms of the same element with different mass numbers. I want to know what has to be the same and what has to be different. All right, so if we are saying that they're the same element, then that means that they have the same atomic number or they have the same number of protons, okay, right? So carbon is element 6, it's always going to have 6 protons. But we're talking about carbon 12 versus carbon 14. So because the mass numbers are changing, that means that the number of neutrons has to be different. And so scientists like to write this in a little bit of an easier way. It's called isotopic notation. So let's move that. Okay, so isotopic notation is just a shorthand way to write the element's mass number, atomic number, charge, get it all in there in one place without having to write it all out. And so the mass number is going to be on the top left, atomic number on the bottom left, and if there is a charge, it will go up here. If the atom is neutral, then nothing will be written in that top right, okay? It doesn't actually matter. So here you have an example of bromine, right? So bromine 8135 with a -1 charge, okay? So that means that its mass number is 81, its atomic number is 35. Sometimes you'll see that 35 left off because if you look at the periodic table, you find Br, it's always element 35. So sometimes people write it, sometimes people don't. I'm not going to be I don't care. You're going to mostly see me write it. But if you choose not to, then that's fine. Okay. It's not wrong. And so from this information, from our isotopic notation, that helps us remember some of these important things to figure out the subatomic particle makeup of your atom. And so mass number, okay, up here, right, this top left, mass number helps you to get your number of neutrons, right? Because if you know the element, you know the protons, okay? That's not hard, right? Carbon, element 6, 6 protons. Oxygen, element 8, 8 protons. Hydrogen, element 1 proton, right? If you know the element, you know the symbol, you find it on the periodic table, protons, done. Okay, so mass number is going to help you get those number of neutrons. Atomic number is going to help you get your number of protons. And then up here using the charge, that will help us figure out our number of electrons. All right, so let's take a look. So for this problem here, we are told the isotopic notation right off the bat. And so this is where it's really important, right, that we remember our elements and symbols. So F, right, is fluorine. And then remember that when we name these things, okay, we want to include that mass number in the name. It's really important. So don't forget to do that with the name. And so remembering from isotopic notation, this little 19 up here, that is its mass number. Now, if there had been a charge written here, we would include it. We don't need to write 0. So atomic number, you think back to your periodic table. You look at your periodic table, you find fluorine. Okay, and my periodic table here is sideways, but go with it, right? So fluorine is right here, and it's element 9. Okay, so that means that if it's element 9, that's its atomic number. And then the mass number, right? We already wrote that in the name. The number of protons, again, that's always the same as your atomic number, right? So give yourself these reminders in your notes. Help yourself out. It's 9. And then what is the number of neutrons? Okay, so the number of neutrons is always going to be our mass number minus the number of protons. So for here, that's 19 minus 9, which is going to give us 10. And I think mine is zoomed, unfortunately. Let's see. I believe there should also be what is the number of electrons written on here, but for some reason it's not showing up on mine. If it was there, which I think it's supposed to be, the number of electrons for something that is neutral, right? So we have a neutral atom here, right? Because there's no charge. And so when something is neutral, the number of protons equals the number of electrons, okay? And therefore we would have 9 electrons in this one. All right, so here is another one. So I'm telling you that it is carbon 14, again, because there is nothing written up here, right? Then we know it's neutral. Okay, and so we go with it. So the atomic number, so we know that we have element carbon. Carbon is, the symbol is C, it's element 6, so its atomic number is 6. The mass number, right, it's given right here in the name, is 14. The number of protons, again, that's the same as your atomic number. And so that's going to be 6. What is the number of neutrons? Again, for here, we're going to take that mass number and minus the number of protons. Okay, so that's 14 minus 6. Which gives us 8. What is the number of electrons? Again, because it's neutral, we know that the number of protons equals the number of electrons for this one. Okay, and again, that's because it was neutral. That's not always the case, just here. So then we're going to have 6 electrons. Then you're asked to write the isotopic notation. So as a reminder, when you're doing isotopic notation, you're putting that symbol in the middle, the charge on the top right, mass number top left, atomic number bottom left. So for this friend, the symbol for carbon is, the symbol for carbon is C. No charge, so we leave that blank. The mass number was 14, and the atomic number is 6. All right, so for these next ones, you're going to go ahead and give them a go. There are 3 problems for you to do. So what I would like for you to do for these 3 problems is you are simply going to just submit your answers into the short answer box, okay? Or if it's a multiple choice, you'll know, okay? And so simply if it's for, like it'll say for this question, go ahead and list. So you could write the name and then atomic number, mass number, protons, neutrons, exactly like that. Okay, so this is the first one I want you to do. Okay, so you've gotten through that one. Now I'd like for you to take a look at this one. Again, submit the answers that you are asked for here. All right, and another one. All right, so the last thing we need to talk about is something called atomic mass. And so one thing that I have seen from you guys in some of these questions you've submitted, you have been plugging in these little numbers right here that are under the elements symbols, 19.00, 16.0, 39.97. So what those are, they are the atomic mass. And so remember, we've said that there's different elements possible, right? Or different isotopes of elements possible. Carbon 14 versus carbon 12, right? Different mass numbers, same element. So the atomic mass is the average of all the possible mass numbers based on abundance of an element. What? The average of all the possible mass numbers of an element based on abundance. And so there's a mathematical equation to do this. And again, it's based on all the different possible mass numbers. So we keep talking about carbon 12 versus carbon 14, but it's not an actual average. If you were to look at this periodic table, the mass number for the atomic mass is 12.01. That's pretty close to the number 12. That is because carbon 12 is much more common than carbon 14. Okay, so again, it has to do with abundance. I'm not asking you to calculate these things. We don't need to. They're already on the periodic table, so we don't need to waste our time. Okay, but again, they're averages, which is why those numbers on the periodic table typically have decimals to them. Okay, so abundance is the key. And so then here you just have a little reminder of where it is. Okay, it's going to be right there. Now, for this class, here's an important thing to note, okay? So make sure you pay attention to the next couple words. I mean, all of my words, but let's take these ones. When we are taking numbers off of the periodic table, you always want to take 4 digits, okay? There are so many different periodic tables, and if you look at the big one on the wall, right, you have a lot of digits there. For this class, always use 4 digits, okay? So write that down. For this class, you must always use 4 digits for the atomic mass. And again, some of these can look really long. The one that I'm using right now on my computer, it's already rounded to 4 digits. 32.07, 35.45, 39.95. But that's not always the case. So like if you look up at the wall and you look at some of these, oxygen is 15.998 or something, okay? And so we as a class are going to use 4 digits every time, okay? And so sometimes that is going to involve some rounding on your part when you're pulling things from the periodic table. Again, the little paper ones typically already have it rounded, but the big one on the wall, or if you're looking at one online, like when you're at home doing your homework or whatever it might be, 4 digits. Okay, so that wraps up our information about isotopes.